Recording. So here's a web history class. Suppose that I want to make this thing so that the web browser just gives us URLs to keep track of this thing. What do I need if I make this class? We'll call it class history, or one of something else. Kinds of variables that our class needs for history, or what? Two stacks. So rather than using our stack, I'll show you the Java one that's already built in. Guess what it's called? Happens to be called stack. And so this is the backward stack. And we'll write another stack for the forward stack. And we'll use our bulbs to go get the Java one. What kinds of things are you going to put in your stack? Which is why the yellow bar is there. Pardon me? URLs. So you said URL, you didn't say string. Okay, so it's going to be a stack of URLs, and this thing is going to be a stack that only holds URLs. I wonder if we get lucky and have a URL class. Oh, look, there's already a URL class. Does something that's supposed to. URL has basically just got a string inside it, but it will be able to decompose that string into various bits and pieces, right? Okay, we need a constructor. So we've got public history, and it needs to initialize those variables. So we'll say back is new stack, and that stack can only hold URLs. And actually, we don't even need to say that anymore in modern Java, so we'll just put in the angle brackets and be done with it. Okay, so there's the stack for going backwards, and there's a stack for going forwards. What's the web browser going to say when somebody types URL and hits the enter key? We need a method to accept that. Might as well be add. So you add something to the history. The thing that you're given is a URL, which is the current web page that we're on. What does it do with that? Puts it onto the onto the back stack, which is the top of the back stack is the current one. Back.push.
You know, this seems to be really similar to what we did.
Oh, you probably did. Okay. Does it have to keep track of the number of items?
Yes. We'll have to remember them, but
Does it have to keep track of how many items are on that back stack?
Well, it depends on if you want to set a hard limit or not.
Yeah, if you want to disable your.
Is there somebody keeping track of it already?
well, the stack class.
The stack class is keeping track of it. So if somebody said how many items are on that backward stack, we'll have to call it back size. How many items are on the backward stack? Good guess. And so adding an item, that thing went away. That was back.push. Got it. How about if somebody hits the back button?
It should push into the forward button mode. And then follow the two pumps that are firing.
If they hit the back button,
Push the result of the pop.
what happens first?
First you wanna pop,
Got to pop Sports Illustrated
push the previous.
off the stack. So
And then back to
old current was back dot, pop the item off the back stack. And then where are you going to put it?
Into forward stack.
Okay, it's really pretty much all there is to it. Let's try the game. What happens if they hit the forward button?
basically switch back and forth.
So this is now, instead of old current, this is going to be now new current is get it off the forward stack and put it on to the that one. What happens in the case of adding to the forward stack? If I've got something on the forward stack and you type a new place to go to,
Clears it out.
clears out everything on the forward stack. Because now you don't have a forward history, you're starting a new forward history of where you're going. So the one thing we have to do here whenever somebody says add is do a clear forward. There's a couple of ways of doing this. You could write a loop that just popped everything off. It turns out that the stack provides forward dot clear to just clear all the items off the stack. That's one way to clear it. The other way would be to make a new stack. Just do this. Okay, that accomplishes the same thing. Throw away the old one, make a new one into the same variable. This one's a little less efficient because new is an expensive operation. So it's actually better off to reuse the old thing by letting the old guy just clear out its stuff.
I'm just not sure. So when you're adding the URL to the stack, aren't you adding, you're gonna add the URL that you're on, so when you hit the back button, you're just gonna go back to the same URL anyway?
No, it's a whole fresh new, when you add, it's a whole fresh new thing that people are typing. So it's never been on any stack before.
Yeah, so what I'm saying is when you hit the URL,
Yeah.
you enter, it goes to that URL, adds it to the stack.
Yeah.
That's gonna be the latest value of the stack. So
Yeah.
the path is gonna be the same URL.
Well, no, because now if somebody says, what's the current one on the stack? What do you give back? You give back dot peak. So now they can always ask, what's the current one on the stack?
Maybe if you look for the back button, maybe you have to push and sort of pop and then peak.
I might have got those in the wrong order. Could be. I'm really not all that worried about there's a completed version in the thing. The only thing that I want to point out is that, yeah, this looks relatively simple, but the whole job of this class is to manage those two stacks to make sure that every time this action occurs, that that action occurs along with it, right? You know, anytime you move one from here, it's going to go over there. Anytime you take one from here, it's got to go back over there. right? Or it's gotta be cleared off, the stack's gotta be cleared off when someone new comes along. So it's not as if it's difficult to write, you can sit down and draw the diagram and get it right pretty quickly. But the whole idea here is that it relieves the web browser of the burden of having to worry about it. The web browser just turns around and says, oh, I got a new URL, I got a new URL, I got a new URL, or give me the current one. And that's all it has to be concerned about. It's not concerned about the management of shuffling these things back and forth. Okay? So that's all this class is doing. And as I've said, you could do this using arrays of things if you wanted, but the whole reason for using the word stack and push and pop is it fits the problem of saying I'm only ever gonna get the most recent one. That's the only thing I care about. I'm ignoring all of the rest. Okay? And so that's more or less, if you look in the notes, that's more or less all there is to that class. It's not particularly exciting. Okay? So that's the easy usage. I just wanted to show that to you to remind you how stacks worked. And now we'll try the more fun usage. Okay, let's talk about a different problem. And I might only get time to sort of half introduce it today. It's Friday night. It's the end of term. You want to have a party, but there isn't a lot of money going around anymore. Student loans have almost run out. Decide that about all you can afford is a couple of cases of beer. There's no place to really party, so doing the high school thing is like, oh, let's go party in the woods someplace. Okay, we'll go back to grade 9, 10, 11, 12, whenever, 7, whenever people did that, right? So it's like, okay, I'm gonna go party in the woods with a bunch of friends, okay? So, here's the trick. We need to go find a place to actually do the partying. So somebody has an acreage someplace, their parents have an acreage, and so it's like, okay, let's go party there. And just to have a little fun, we decided that what we're gonna do is in this big forest on their acreage, we're gonna put the beer someplace in some clearing where we're gonna build this bonfire and, you know, drink beer all night, keep warm. So way out in the acreage someplace, somebody's put the beer in the acreage, right? And so everybody sneaks over, the parents are gone on Friday night, everybody comes over and they're sitting in the house and they're going, we guys should make a game out of this. We're all a little too lazy to go figure out where the beer is in the forest. Why don't we send one of our friends to go hunting for the beer in the middle of the night with their flashlight, see whether or not they can find the beer, and then let us know where it is. Okay? And so, if you've ever been through forests, grapes and bramble forests, you know that forests typically have all these little deer paths. And so usually what happens in the forest is that it's just all brush that you can barely go through, except you can see sort of a couple of places where you could probably make your way through that the deer have gone through. And so you follow one of those things and you end up in this sort of semi-clearing where there's not too many trees, and then you can see that there's some other places that you could probably have paths cut through the forest in order to get through, right? So you can sort of follow the paths. If I were to draw a diagram of that, the diagram would look something like this. Here's the place where we start, which is the house. And then from the house, if you go and look, there's a bunch of different deer paths, trails that you can take. And if you take one of the trails, you eventually come across a clearing. And then from that clearing, there might be another couple of trails that branch off in various weird shapes, and then there's more clearings. Okay? And so if we draw a nice map of it, you eventually end up with something that looks like this. Okay? And so now we've got this map sitting in the house. Somebody's sort of mapped it out for us. And we know that for some reason somebody's come along and hid the beer someplace in the forest. Okay? So almost nobody knows where it is. So we'll put the beer someplace. Okay? And so now we decide to have a little fun with our friend. So what we do with our friend is we say, well, okay, we're not going to tell him where the beer is. We're going to give him one of these maps. And then what we'll do, just so that we can identify these things, is we'll put numbers into all of these things. So there's we numbered all of the clearings. Okay? So now 10 of us are going to sit in the house. where it's nice and warm. We're gonna send our one friend out, and we're gonna say, go find the beer. Okay? What we want friend to do is we want friend to get on their phone, and we want friend to say, oh, okay, I'm starting at the house. Oh, there's no beer here. Where am I gonna go next? Oh, I'm gonna go to clearing number 1. Oh, there's no beer there. Let me go to clearing number 4. Oh, there's no beer there. I'm going back to clearing number 1, already checked that. Oh, I'm going to clearing number 5, no beer there. Oh, I'm going from 5 to clearing number 9, no beer there. Oh, I'm going back to 5. Okay, so I want friend to give the play-by-play description of them running through the forest, through all of the places that they're going to, just so that we've got a little fun, right? Make them do all the work. Eventually, friend is gonna come along and discover the beer. Okay, and now they go, aha, the beer is at clearing number 11. Now the goal is we have to get to clearing 11 as fast as we can go before friend drinks all the beer. Which means that we would like friend to say, I found the beer at clearing number 11, and if you want to come and join me, I want you to go from clearing 0, 2, 6 to 11 and join me for the beer. So they've now given us the shortcut. We don't have to play the game. Okay? There's the game. Now, I want you to turn that into a Java program. And not only do I want you to turn it into a Java program, but I want to arbitrarily be able to change this forest to a totally different forest with beer in a totally different place and still have the same code work for the different forest. So, if we were to start writing this code in Java, your first temptation was to say, oh, this is really easy. I'll write an if statement here. If beer at clearing number 0 is true, then found beer, else, oh, there's another if statement, else if it's clearing number 1 that has the beer, else if it's clearing number 2. That's gonna get really ugly really fast if you just write a bunch of if then elses to try to check this. So if then else isn't gonna work because it's gonna be too much code and it's only gonna work for this specific forest, and you're gonna have to change the if then elses. Seems like an ugly problem, doesn't it? Seems like it could be a lot of code. Any suggestions? Stack. Let's use a stack. Wow. How could you possibly have figured that out? Here's a stack. Oh, sneaky question. What should we call a stack? You're right.
Successful path, because once you get to the point that it knows where it needs to go, then you just have to pop it off one by one to establish the path it took.
So, in this problem, the trick in the code is that if I decide to check going from 0 to 1, the problem is I've got some other bunch of stuff that I have to remember that I haven't done yet. Okay, one more time. If I'm gonna do this one, there's a bunch of other things that remain left to do that I have to get back to at some time, possibly. So when you have a problem that says I have to get back to doing some stuff that I haven't done yet, then the stack becomes the thing that you should use. And in this case, I can make it really, really clear with one name. We'll call this our to-do list. Okay? So here's the way we're going to operate. What we're going to do is on my to-do list, I'm going to start by placing the thing that I have to do. The thing that I have to do is go investigate clearing number 0. That's what's on my to-do list. Here's where the algorithm starts. Now, anytime I'm just sort of standing around and I've got nothing to do, somebody says, go look at your to-do list. To-do list says I should check number 0. Oh, okay. Let me go check number 0. Any beer there? No. What do I have to add to my to-do list? All of the things that I should get to at some point in time that I haven't done yet, things I have to go back to and do sometime later. So I'm going to put the things that I need to get back to and do sometime later onto my to-do list. Oh, got nothing to do. What should I do now? Oh, wow, there's something I could do. Let me check number 3, right? So I checked the number 0 already. Let me check the number 3 thing. I'll take that off my to-do list. I'll come and check the number 3 thing. Any beer there?
No.
Oh, well, if there's no beer at 3, it's gone. What do I have to do? I guess at some point I should come back to checking the things that I can get to from 3. Standing around, nothing to do. What should I do now? Oh, let me check number 8. Any beer there? No. Crossed 8 off the list. What do I have to do now? I should check the next thing on my to-do list, which is number 2. Oh, okay. Done that, I guess I can move over here and start checking that one. Okay. Eventually what will happen is all of the things will appear on the to-do list because you're using this to keep track of the things that you haven't gotten to yet. At some point you'll have gone through and magically checked all of them and you'll arrive at the place that you haven't gotten to.
How do you trace the path back from 11 to 12?
Oh, the question is how do you do the path back? That's a different problem.
How do you populate
So-
the list?
Okay, so we started out with the simplest thing first, right? Everybody convinced that it will work?
Sure.
Do I need to do it again for anybody who's unconvinced? Okay, so there's the first issue is how do I at least make sure I've gone through all of the possible things and done them when I can only check one at a time? And the thing is really easy. Anything that you haven't done yet that you want to get back to doing, you just throw it onto the to-do list, which is really a stack because you're only ever dealing with the first thing that you have to do. Easy. The big problem with this is that at some point we come along and we have this path to the beer, but we no longer can say what that path is, right? The reason we can't say what that path is because we've wiped stuff off the to-do list.
At any given point, the smallest number of clearings that you have direct paths to is the path back.
Well, there's an easier way. Let's start out and let's do something just slightly different. Play the game again, all set up to go, got the beer placed in the forest. Here I am with number 0. Now what I'm going to do is I'm going to say, oh, any beer at 0? No beer. I'm going to leave that on my to-do list, and I'm just going to mark it, leave a little breadcrumb, play Little Red Riding Hood, as some place that I've been to. And now I'm going to add the same stuff I did before onto the list. Okay, so now I go to check number 3. I've got this one marked. Any beer at number 3? No, but I'll mark it. Still no beer. Where do I go to next? So now we have to add, when we're at 3, we have to say, oh, there's nothing left to do, or at 3, we need to add 8. Go look at our to-do list, check 8. No beer at 8, but we'll mark it. If somebody says, how do I get back to the house? All the breadcrumbs, all of the ones that are marked are how to get back to where you came from. That's what stacks are for. Okay? But on our to-do list, we've got this little problem. If there's no beer there, what do I do when I consult my to-do list? And I see one that's already been marked. Just throw it away. Already been there, done that, no beer there, not interested. Okay? That says go back from 8 to 3. Oh, it's already marked, been there, done that, no reason to keep track of that. Until finally, you get back to something that's never had a breadcrumb on it before, and that's where you need to go next. Okay, so now if I mark this one, look what the path now says. Go to 0 to 2 is how you're moving along through the forest. Okay, so the marked ones will always contain the path of how to get back to the beginning. Okay, so eventually what will happen is you'll have some marked and some marked. Okay, one other thing here. Suppose from 2 we do 6 and 7. We mark that one for 7. If somebody says you're at 7, where are you going to go back to retrace your steps? You go when somebody asks the question, where are you going back to? The answer is the first one that's marked on the stack says this is where I'm going back to before I move forward again. Okay, so this stack is actually serving 2 different purposes. It's keeping track of what's the path, and it's also keeping track of the undone ones, and that's the easiest way. By the way, you've seen stacks in a programming language where the stack keeps track of a couple of things. It's got not only where to get back to, right? In assembly language, do a subroutine, take the top one off the stack, that's where I need to go back to. But the stack also has all of the current variables on it for the variables that you're using right now in the registers for your subroutine. So when you go back to, you get rid of the variables, and then you go, okay, I have to take this step back. So the stack in a programming language is being used for 2 different purposes, both for the variables and for the going back to. So we're going to do the same thing here. Okay? So it turns out that this thing goes from being what looks like a really horrendous programming problem to something that's actually going to be fairly simple and straightforward. It's just a little tiny algorithm that plays with our to-do list and has a few if statements in it. Okay? So let's try the beer hunting game, translate this into Java. Okay? So I've made a project here called Forest, and I need to start out and keep track of some stuff. What's the smallest thing in the problem? The clearing. Okay, well that's fine. How about class clearing? What information does a clearing keep track of? It keeps track of the number, which is its identifier. It keeps track of whether or not there's beer, which is a Boolean. It either has beer or it doesn't. And there's going to only be one place, hopefully, that has beer. And what else does it keep track of? Pardon me? Connected clearings. So that's private. What do you want to use to hold the connected clearings? What are your choices? Array list, linked list, or array directly, right? Just for convenience sake, let's do it with Java's array list or just any list. what's gonna be, what's gonna list gonna hold? It's gonna hold, it's gonna be a list of only other clearings that you can get to. And so this is, what do you wanna call it? Other clearings? Next clearing? What's a good name for it? It's not current, it's just where you can get to from here. Connected clearings? Sure, I like connected clearings. That's got to be an import statement. Should write the constructor. Identifier must be supplied to us since we obviously don't have it. So that means there has to be something coming in there. How about has beer? What do you want to set it to? The standard thing is it's almost always going to be no beer, except for the one special case that has beer. So what we'll do is we'll supply a setter for that one special case. And it can just set it to whatever it needs to. So that will probably be true. Okay, so almost always it's set to false. When we decide where we're going to put it, we can change one of them afterwards to say that's the clearing that has the beer. Okay, what about connected clearings?
Are we writing code that generates the first
We're just talking about one clearing, and you're initializing it.
Just a new array list.
Where's it getting that list of things from? It doesn't know. So somebody's got to supply it. So there's got to be a list of in-connected clearings, just like we've always written. So somebody's got to supply us this information so we can initialize just one of them. So what should you do to set connected clearings? You could do this. In would be a better thing. What does that do to the two lists? Are they independent or not?
No, yeah,
They're not. In this case, it probably doesn't matter because we're never going to change it. What would you do if you wanted to do the safe thing and make a copy?
what do you do, copy that?
How would you copy it? Make a new list and add them? Is there a shortcut for that?
Just copy that. Insert copy method.
Yeah, there is. Here's array list. And array list has the convenience method to do the copying for you, that you just have a separate constructor that says, here, these are the ones I want you to initialize it with. So it will go through and do the dirty work of taking things out of the original and placing them where they belong in the other, which you might have noticed we basically did already in a lot of your code. So it's not a lot of magic to write, but it's just a simple convenience method. And this is an array list of only clearings, just to get the yellow bulb to go away. Okay?
So it's an array list now instead of a list?
List is, you can't make a list. List is an interface.
Oh, okay.
So array list is the kind of list that actually has an array underneath to do the work. Okay, so there's our bunches of clearings. Let's leave it at that. Eventually, at some point, we're going to want to write some getters here to retrieve specific clearings, but we'll just leave this for now until we have a point where we have to actually do something with it. Okay, now that we've got our clearing, there's one of, what are you going to do for the main program? Start a main program going. How would you make one clearing? What information are you going to pass to make a new clearing? The ID number of the clearing and what else?
Whether it's got beer on it?
It's always going to have no beer to start with. What it's going to connect to. What would be the simplest thing?
The number of clearances connected to.
It would be nice if we could just say the numbers. It's connected to 1, 2, and 3. So the thing that you would probably want here is an integer array of the numbers 1, 2, and 3. And closing brace. It's almost right, and a semicolon. Oops. Yeah, it's just going to be upset because that's not what our constructor says. Oops. Plus I've got an extra brace there someplace. Oh, it's going to be a new integer array. That's a little better. Something like that. Oops. Almost right. I'll fix the syntax a little later. I can't remember whether I need the equal sign or not. You know, that's what makes it go away. Something like that. I guess my point here is that in terms of making this clearing, it's more obvious in this case to work with something that looks like just the numbers. And because of that, we should probably do something here where we don't pass in a list of clearings, but what we pass in instead is just an integer array of numbers. Okay, so that would be integer number list and that's going to be an integer array of just the clearing numbers that we're going to have. Okay, so using, in this case, array list isn't really our friend here because it just sort of hides the fact that they're just numbers. And so the better thing to put in here, or one of the things that we can put in here, is we could just change this thing to be an integer array of clearing numbers. Okay, so we just have to store the numbers at this point of where to find the other clearings. And so our clearing numbers, we'll do the same thing here. And instead of making that an array list, I'm just going to assign this thing to number list. So that doesn't make a copy, but we'll worry about that later. And then we'll go into our driver program and we'll just try to get the syntax right for one of them. This is a new integer array with just the numbers 1, 2, and 3 in it. There we go. Let's get that out of there so you can see it. Just because if we're doing the second clearing, oops. the second clearing becomes a little bit more obvious. I'll just call this first, and I'll call this second. So our first clearing hooked up to the numbers 1, 2, and 3, and clearing number 1 from our diagram hooks up to clearing numbers 4 and 5. Okay? So my point is that if I get it down to that sort of array-based notation, it's really obvious I can go right from this diagram. 0 needs to be connected to 1, 2, and 3. 1 needs to be connected to 4 and 5. I can start to make a list of variables that are going to correspond to what those clearing numbers should be. Rather than a list of variables, one final little step. This is going to become first, second, third, fourth, all the way to 100. So this is not just first, second, third, but it's an array of all of the clearing numbers. So let's put that into an array. So that's a clearing array that will hold more than one clearing variable. And I'm just going to wipe out first, second, third. And you end up with something that looks roughly like this, I think with a semicolon at the end, if I remember right. Oh yeah, and this is commas. Oops. Just to get the syntax right. And an equal sign somewhere along the line. There we go. Okay, so I'm going to fill this thing out to be just basically an array or a map that keeps track of clearing number 0 goes to 1, 2, and 3, clearing 1 goes to 4 and 5, clearing 2 goes to whatever, and I'm just going to have basically a table that corresponds to this map. And the joy of that is that if I make a table of things and somebody says here's a new map, we just go and we make another table that represents whatever map we've got, and now this thing is the only thing that has to change, and we're not going to change any of the code underneath. So I'll fill this out with our data, and then tomorrow we'll figure out how to write the algorithm to make that thing actually do its work.